अभी क्या हरकत कर रहा है जा अच्छा के लिए ये तो स्टाइल तुझी गेली ये पैसे अंगात आली जात बोलू नका म्हणजे ना 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 पुढे तुझा फोन आता बाहेर जा हॅलो 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 So good evening, students. So today we are going to start with a new chapter, that is D and F block elements. Okay. So in the periodic table, you have seen there are different groups. Okay, S block elements are there, P block elements are there, D, F, right? So these are the different groups of elements which are grouped, okay, in the periodic table. So S block and half P block, you have studied it in the first year. So D and F block, you're going to study in this particular year. Okay. So other P half. Okay. So it has been deleted from your chapter, but after completing the syllabus, okay, of this year, we will be continuing with the deducted part. Okay. Whatever has been reduced, so that part we will study after completion of this chapters which are there. Okay. So D and F block elements. So what is D block elements? So D block elements, these are defined as the elements which are having partially filled D subshell. Okay. So they are having what? They are having partially filled D subshells in their atomic or ionic state. Right. So where they are placed in the periodic table, S block, okay, when you see the periodic table, to your left side are your S block, and for your right, on your right hand side are your P block. Where are D block and F block elements? They are placed in the center. Okay, this place in the center of the S and P. So they are placed in the center. So D and F. So D are placed first, and then comes the F series, right? So these are partially filled D subshells. So in this elements, the D orbitals which are there, they go to the penultimate shells and they gradually get filled with the electrons. Okay. Hence, what is the general formula of D block elements? Yes, can anyone tell me what is the general formula? General electronic configuration?
N minus 1, 1 to the power 1 to 10, ns2.
Yes, N minus 1, N minus 1, D, okay, 1 to 10, and ns 1 to 2. So this is the general electronic configuration of D block elements. So remember this general electronic configuration, very important. Okay, so general electronic configuration is very important. So this is the general electronic configuration of D block elements. So which are the 4 series? So in D block elements, there are 4 series. So that is 4 series are there in D block elements, namely 3D, okay, 3D series, then 4D series, then comes 5D series and 6D series. So these are the different series which are there in D block elements. So so accordingly the elements will fill. So according to the filling up of first the 3D orbitals will get filled, then the 4D electrons, the 4D orbitals will get filled, then the electrons will go next to the 5D and then 6D orbitals. And the 6D series, they are still incomplete. Okay, so so still elements are to be added. So the 6D series, they are incomplete. So these are placed So where are these placed? As I have discussed, they are placed in the center, okay, in between S block as well as in the P block elements. So they are placed between highly reactive S block. So you know that S block are highly reactive and P blocks are also highly reactive. So the placing of these elements, they are placed in the center, okay, between the highly reactive S block as well as P block elements. So because of this, these are called as what? These are called as transition elements. So as they are placed between the highly reactive S block and P block elements in the center, they are called as transition elements. So the group 12, okay, elements, that is zinc, cadmium, okay, mercury, they have completely filled d subshells in their atomic form as well as the ionic form. Hence, these elements, they are not included in D block, and therefore these are called as pseudo transition element. So there are certain elements which acts as D block elements, okay, but they are not D block elements. So the elements like zinc, okay, then cadmium and mercury. So these are the elements, they have completely filled D subshells, but they are not included in D block elements. So these are called as what? These are called as pseudo transition element. Okay, these are called as pseudo transition elements. Pseudo transition elements. Okay, the electrons are filled, the d orbitals are filled, but they are not included in 3D series. That is, they are not included in D series. So these are some of the key features you can say about D block elements. So first we are going to see about the D block elements. So next we'll see what are the properties. Okay, what are the general properties? So all this, so what are the transition metals? So these all transition metals, they are metals. Okay, so all the transition elements here, they are all metals. So they possess the characteristic properties of metals. You know what are metals? They have a shiny surface. Okay, they have a shiny surface, they have high tensile strength, they are having the properties like malleability and ductility. Malleability and ductility means what? They can be converted into sheets and thin wires. The metal, okay, it can be converted into thin sheets and thin wires, and they have thermal and electrical conductivity. They are good conductors of heat and electricity. For example, copper. So copper wires are used where? They are used in the electric wiring. Why? Because they are good conductors of heat and electricity. So because of these properties, so all these transition elements, they are metals, and these are having the characteristic properties of metals. So also these transition elements, they are having high melting and boiling point. Why? Because of the stronger interatomic bonding. So because of the presence of interatomic bonding, they are having high melting and boiling point. The atomic and the ionic radii of the transition elements are smaller than those of S block elements, but larger than those of P block elements. So when you're talking about atomic and ionic radii, so as you know, as you go across the period, what will happen to atomic and ionic radii? It goes on decreasing, right? As you go across the period, the atomic and ionic radii, it goes on decreasing. Why? So as for S block, the atomic radii will be smaller, okay, than that of S block. The atomic radii of transition elements are smaller than that of S block, but they are larger than that of P block elements, because as you go across a period, it goes on decreasing. Okay, and as you go down the group, you know, it will go on increases because of the addition of new subshell, and across a period, why it is going to decrease? Because of the effective nuclear charge. So remember these reasons also. Then the next point, transition elements, they exhibit higher enthalpies of atomization due to stronger interatomic bonding. So they are having higher enthalpy rate. Okay. Then among the elements of the first series, zinc has the least enthalpy of atomization. Next, among the elements of the 3D transition series, scandium does not show variable oxidation state, while manganese shows a maximum number of oxidation state. So not so important. Next, transition elements, they form colored complex. Yes, so very important. So why does transition elements, they form colored complex? So the color of the complex, it is due to the absorption of light energy. Okay, so when the electrons are present in d orbitals, so most of the d orbitals, when they are having electrons filled, they will show colored complex. Why they are showing colored complex? Because the color of the complexes, because they absorb the light. Okay, they absorb the light energy due to dd transition in partially okay, due to dd transitions in partially filled d orbitals. Okay, so from what will happen, the energy will be absorbed and the electrons will get excited from lower energy level to higher energy level. Then again, the electron which is getting excited at the higher energy, so it has to come down. So when it comes down, what will happen? They will emit the light. So because of this, they will be colored complexes. So due to dd transitions, remember, due to dd transitions in partially filled d orbitals, transition elements are colored complexes. Very important note. Then the first series of transition metal oxides are generally formed by reacting metals with oxygen at high temperature. So metal oxides, how they are formed? By reacting your metals with oxygen at very high temperature. Okay, so these oxides may be acidic in nature, may be basic in nature, or may be amphoteric in nature. Amphoteric means what? They will act both as acid as well as base. Okay, so the metal oxides, how they are formed? By reacting metals with oxygen at very high temperature. The first series of transition metal oxides. Okay, they are formed by reacting the metal with oxygen at higher temperature. These oxides, they may be acidic, they may be basic or amphoteric in nature. These oxides, they dissolve in acids and bases to form oxometallic salts. Okay, so the corresponding oxides which are produced, they can be dissolved in acid and bases and they form oxometallic salts. Then some oxometallic salts, some of the example, very important examples are, so these compounds we are going to study. So the important oxometallic compounds, salts are, this is potassium dichromate. Okay, potassium dichromate, potassium dichromate, this is KMnO4. Okay, so manganese, so the potassium manganese, so these are all common examples of oxometallic salts. So these are some of the important what you say, oxometallic salts. Then so they have given, so we'll see about lanthanides later. Okay, first we'll complete about, so second. So first we'll complete about D series. Okay, because again, you should not get confused. So first we'll complete about D series and then we'll go to the F. Okay, so D block and then followed by F block we will see. So D series, so we are going to see some complex compounds also. So we are going to see about the formation of compounds. So these are the important compounds which we are going to study, that is potassium dichromate. Then we are going to study about potassium permanganate. Okay, potassium permanganate is also there for your syllabus. And one more compound, these two you are going to study. Okay, so potassium dichromate, potassium chromate, and potassium permanganate. So these are some of the compounds which we are going to study. So lanthanide series, that is F block, we will see after completion of D block. So next, so what are the general properties? So first we'll see what are the general properties, that is general properties of transition elements. So these form stable complexes. Okay, so as the electrons are present in D block, so you know most of the D block elements, they form stable complexes. Okay, so what are complexes? So these are, so metal and ligands. Okay, so metal and ligands, they form the stable complexes. So they have high melting point and boiling point. So transition elements, they have high melting and boiling point. They form compounds which are often paramagnetic in nature. What do you mean by paramagnetic? There will be free electrons. Okay, The electrons here are unpaired. So whenever the electrons are unpaired, they are said to be paramagnetic. They are attracted, okay, they are reflected by the magnetic field, and thus it is paramagnetic in nature. So they form compounds which are often paramagnetic in nature. Paramagnetic means the electrons are free. Okay, they are unpaired. They are not paired. In diamagnetic, the electrons are paired. Okay, so these compounds, they are often paramagnetic. They are hard. So the transition elements, they are hard, and they possess what? They possess high density. They high density. Why density? Because density is nothing but mass plus volume. So because the mass is higher, okay, volume is higher, the what will happen? The density will be more. So they have a higher density. Then they form compounds with profound catalytic activity. Okay, so they show some catalytic activity. They show variable oxidation state. Variable oxidation state means what? They will show various oxidation states. So they may show different oxidation states. So one particular element, they may show variable oxidation state. They form colored ions and compounds. So due to DD transitions, as we have discussed, they show what? They show colored ion and compound. So these are some of the key what do you say, properties of transition elements. Okay, so next, we'll see the metallic character. Okay, how is the metallic character of D block elements? So these metallic, all the D block elements, they are mostly metals. As we have discussed, all the D block elements, they are mostly metals. Okay, as the number of electrons in the outermost shells are 1 or 2. So as the electrons which are present in the outermost shell, they are 1 and 2. So because of this, all the D block elements, they are what? They are mostly metals. They are hard. Okay, so as we have discussed, the metals, what are the properties of metals? So metals are generally hard. They have malleability and ductility, except mercury. Okay, 1B group elements, that is copper, Ag and Au, that is silver and gold, are most ductile and soft. So you know the property like ductility and soft. So they are soft in nature. Okay, so they are hard, malleable, and ductile. So 1B group elements like copper, gold and silver, they are mostly ductile and soft. Then these are good conductors of heat and electricity. So these are also these are the characteristics of metals. So these are good conductors of heat and electricity. Why? Due to the free electrons which are present. So elements of 1B group are most conductive in nature because of the conductivity of the order Ag is greater than Cu is greater than Au is greater than aluminium. Okay, so this is the increasing series. Then covalent and metallic bonding both exist in the atom of transition metals. So these are certain properties. Then the presence of partially filled d subshells, they favor the covalent bonding and metallic bonding. So because of partially filled d orbitals, okay, so the electrons which are filled in the d orbitals, as they are partially filled means what? They are not completely filled, they are half filled. Okay, partially means they are half filled d orbitals. So because of the partially filled d orbitals or d subshells, they favor covalent bonding and metallic bonding. So because of partially filled d subshells, they favor covalent bonding and metallic bonding. So these bonding are favorable also due to possession of 1 or 2 electron in outermost energy shell. So because you know in the outermost shell there are 1 or 2 electrons present, so because of this, they favor covalent and metallic bonding. Okay, so these are certain metallic characters of d block elements. Next is, what is the reducing power? So reducing power of d block elements, they depend on the electrode potential. Okay, so reducing power means what? It reduces other and itself undergoes oxidation. So reducing power of d block elements, they depend upon the electrode potential. So it can reduce other and itself it will go oxidation. Okay, so standard electrode potential, that is standard oxidation potential of copper, will be minimum in the 3D series. So 3D series is the first series, okay, in d block elements. So it is the least reducing elements in the d series. So copper will be having the least reducing value, okay, in the 3D series, and Au, okay, that is gold is the least reducing element in the 3D block because of the highest positive value of standard reduction potential, because the value, okay, it has the highest positive value of standard reduction potential. So if you see the series, that is electrode potential series, okay, you can see the different values of different elements. So based on the standard reduction potential, it will have the highest value. So because of this character, it is least reducing element. The poor reducing capacity of the transition metal is due to high heat of vaporization. Okay, it is due to high heat of vaporization. So it is due to high heat of vaporization. Okay. Then high ionization potential. What is ionization potential? It is the energy which is required to remove the last electron from an isolated element. Okay, isolated element. So high ionization potential. So because of this reducing capacity of the transition metal, it is due to high heat of vaporization, due to high ionization potential, and low heat of hydration of their ions. So because the reduction potential, it depends on all these three factors. So whenever you're talking about reduction potential, it depends on mainly these three factors, that is heat of vaporization, ionization potential, and heat of hydration. So these are the three factors on which the reduction potential depends. Next is density. So the atomic volume of the transition elements are low compared with the S block. So their density is comparatively high. So why density? Because mass is higher. If mass is higher, density will be automatically higher, right? So osmium is having 22.57 gram. Okay. And iridium is having 22.61 gram. So they have the highest density. In all the groups except the 3B, there is normal increase in density from 3D to 4D series, and from 4D to 5D series, it increases just double due to lanthanide contraction. So we are going to see lanthanide contraction in F series. So because of lanthanide contraction, there is slightly increase. Okay. So in as you see the different series, so there will be slight increase from 3D to 4D. That is as you go from top to bottom of the elements, it will go on increasing. Okay, density goes on increases, because as you go down, the mass increases. Okay, so these are certain properties of. So this is the property, density property. Next, we are going to see is melting and boiling point. So what is melting and boiling point? Melting and boiling point of D block elements is greater than S block elements. Why? What is the reason? Because stronger metallic bond is present. So as you go across this, what will happen to metallic bond? It goes on increasing, and presence of a covalent bond which is formed by unpaired D electrons. So in D block, it is partially filled. So because of the partially filled electrons and the presence of that is a stronger metallic bond, okay, so covalent bond will be more stronger because of unpaired D electrons. So because of this reason, melting and boiling point of D block elements is slightly greater than that of S block elements. Then in zinc, cadmium, and Hg, okay, that is mercury, there is no unpaired electron which is present in D orbital. Hence, due to the absence of covalent bond, melting point and boiling point are very low in this series. So because these metals are said to be volatile metals, volatile means volatile. Okay, so they can easily vaporize. So Hg, it is in liquid state. So because of this, so there is no unpaired electron which is present in the D orbital. So these are three metals are volatile in nature. Okay, so next is in 3D series, scandium to chromium melting and boiling point increases, and then manganese to zinc melting and boiling point decreases. So from scandium to chromium, when you see the series, what will happen to melting and boiling point? It increases, and then from manganese to zinc, the melting and boiling point decreases. So as the number of D electron increases, the number of covalent bond between the atoms are expected to increase up to chromium, okay, to MO2W family, okay, where each of the d orbital has only unpaired electrons and the opportunity for covalent sharing is greatest. So these are certain melting and boiling points. So remember, first 3 points are very important. So first 3 points, that is melting point and boiling point of D block is greater than S block. What is the reason? Due to stronger metallic bond and presence of covalent bond, which is formed by unpaired d electrons. And zinc, cadmium, and Hg, there is no unpaired electron. So because of this reason, there is absence of covalent bonding and melting point and boiling point is very low. And these are volatile metals. So these 3 important points you remember in melting and boiling point. Okay. Next is formation of complex compounds. So the transition metals, they form a large number of complex compounds. Why? Because of comparatively smaller size of the metal ion. So as you see the size, as you know, across the period, what will happen to atomic size? It goes on decreasing. So because of the smaller size, what will happen? The transition metals, they form a large number of complex compounds. Okay. So they are having high ionic charges and the availability of d orbitals for bond formation. So because of the smaller size, high ionic charges and availability of d orbitals for bond formation, most of the transition metals, they form complex compounds. So these are the reasons. Okay. So what is the so remember this, why transition metals, they form large number of complex compound. So these 3 points you keep in mind. Okay, high that is smaller size. Okay, it is due to smaller size. Smaller size, then high ionic charges and availability of d orbitals for bond formation. So these are the 3 points you need to remember for formation of large number. Why large transition metals, they form large number of complex compounds. So these are the 3 important points. Next is catalytic properties. So most of the transition metals they are used are catalytic. Why they are catalytic? Because of presence of incomplete or empty d orbitals. So because of incomplete of d orbitals, they are behaving as catalyst. Okay, they are behaving as catalyst. So what is the use of the catalyst? So they enhance the activity. Okay, without alteration of any reaction, the catalyst, they will forward the reaction. They will the activity of the reaction will be forward. For suppose if a reaction is taking for 1 hour, okay, so if you make use of catalyst, it can the reaction will remain the same, but the rate of the reaction will increase. So it may finish in 10 minutes. So the reactants, they will be converted into products with the help of the catalyst in 10 minutes. So catalyst, they will enhance the rate of the reaction. So most of the transition metals, they are used as catalyst. Why? Because what is the reason? First reason, because of the incomplete or empty d orbitals. Second, it is due to large surface area. They have a large surface area. Third, they have the property of showing variable oxidation state. So they can show variable oxidation state, means they can show different oxidation states. Then they are having ability to form complexes. So this is the fourth point. So most of the transition metals, why they are used as catalyst? Incomplete or empty d orbitals, large surface area, variable oxidation state, and ability to form complexes. So these are the elements which are used as catalysts. Please make these points as notes. Okay, whichever I am marking as important, whatever is important, I am just highlighting them. Please make it a note. So it will be very important for you all also. So for theory as well as for competitive. Okay. So please make everything this as note. So next is formation of interstitial compounds. So transition metals, they have voids. Voids means what? Small spaces. Okay. Or interstitials. Interstitials means also small spaces. For example, this. Okay. This is called as a void. This is called as a void. Okay, 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 this is c this is called as a void, or it is called as the interstitial species. Means what? Between the larger atoms, when you have small spaces, they are called as the interstitial spaces, or they are called as the voids, in which now if there are large atoms, okay, in between the large atom, if there is small space, so some atoms like carbon, hydrogen, nitrogen, boron, as you know, the mass is very small, so this can be fit, okay, they can fit in this space, and they form they lead to the formation of interstitial compounds. Okay, so whenever transition metals, as a transition metals, they are larger in size, so they have voids. Okay, they have voids in between, so these voids can be filled by atoms such as carbon, hydrogen, nitrogen, boron, so they can fit in this, and they result into the formation of interstitial compounds. So these are called as non-psychometric, that is their composition is not fixed. So how much atoms are fixed into the voids, it is not fixed, so it is called as non-psychometric. Okay, psychometric means the ratio is fixed, their composition is fixed. Non-psychometric means the ratio is not fixed. So for example, steel, so they are harder and less malleable and ductile. So this is the formation of interstitial compounds. So these three important points, please make them a note. Okay, so transition metals, they can form large number of complex compound. What is the reason why they show catalytic properties? Okay, why most of the transition metals, they show catalytic properties, and what leads to the formation of interstitial compounds? So these 3 points, please make them a note. Next property is alloy formation. So alloy is a homogeneous mixture which is made up of 2 or more metals. So alloy means what? When 2 or more metals, okay, they mix. So when they are homogeneous mixtures, so homogeneous means what? There is uniformity. Okay, there is no separate layer, uniform mixture. So when it forms a uniform mixtures between 2 or more metals due to comparable size of transition metals, one metal can displace another metal in the crystal lattice, and this results in the alloy formation. So whenever some transition metals which have similar size, okay, which are having similar or comparable size, so one metal can displace the another from a crystal lattice, and this leads to the formation of alloy formation. So whenever you want to form any alloy, okay, so the elements which are having similar size, so one the metal can be replaced by the another, and this leads to the formation of alloy formation. Okay, so the alloys so formed will be hard and they have high melting point. So these are some key features. So from transition metals, you can do alloy formation also. Okay, so this is also one of the characteristics. Next is it has color property. Why they are having color property? Yes, why they are having color property? Most of the transition metals, they exhibit color property. What is the reason why they show color property? Due to DD transition. Point, make this also a point. So most of the transition metal, they exhibit color property. It is due to DD transition of unpaired electrons in their T2G and EG sets of d orbitals. So this T2G and EG, we are going to see it in coordination compounds. Okay, what is T2G and EG sets of d orbitals? So T2G and EG, okay, so whenever you have a degenerate set of orbitals, degenerate set of orbital means what? These are said to be degenerate, means what? All the d orbitals are having equal energy. You know, in d orbitals, there are 5 orbitals, right? So these all 5 orbitals, they are having equal energy. So they are said to be what? When they are having same energy, it is said to be degenerate. Degenerate. Okay, so degenerate. So when you supply some energy, these orbitals will split into 2. Okay, so here 2, here 3. So this is T2G and this is EG. So T2G and EG. So this is called as, so when they are separated by a barycenter, okay, so it is a barycenter. So they are separated by a barycenter. So they require less amount of energy to undergo excitation of electrons, hence they absorb visible region of light exhibiting color. So they require amount of energy, the less amount of energy is required for excitation, okay, of electrons. So what they do, they absorb the visible region of light. Due to this, they exhibit color. So these are the important points for color property. So due to DD transitions of unpaired electrons which are present in T2G and EG sets of d orbital, okay, they require less amount of energy to undergo excitation of electrons, hence they absorb visible region of light which are exhibiting color. So example, scandium plus 2, that is argon 3d1, titanium plus 2, argon 3d2, V plus 2 vanadium is argon 3d3. Okay, so the number of electrons which are present are less and they are unpaired. Okay, they are unpaired. So because of this reason, the energy which is required to get excited from lower energy to higher energy, the energy which is required is less. So when it get excited, okay, they will be unstable. So they'll come back to the ground state. That time they will absorb the light in the visible region. Okay, and thus they exhibit color. So this is the characteristic of a transition element, that is color property. Next is magnetic property. So magnetic property, generally the transition elements, they exhibit magnetic property. A paramagnetic substance is one which is attracted into a magnetic field. So whenever paramagnetic, as I said, paramagnetic is what? Paramagnetic means unpaired electrons are present. Okay, they are unpaired electrons are present. So whenever unpaired electrons are present, they will be attracted to magnetic field. So paramagnetic property is mainly shown due to presence of it is due to presence of unpaired electrons in the atoms or ions or molecules. Okay, so it inversely proportional to temperature. So magnetic paramagnetic property, it varies inversely with the temperature. So please make this point important, the first one. Then what do you mean by diamagnetic substance? Diamagnetic substance is one which is slightly repelled by a magnetic field. It is independent of temperature. Okay, as uh, as it is evident, most of the transition metals, they have unpaired electrons in the d orbitals. Hence most of the transition elements are magnetic in nature. So these are the examples. Okay, so as most of the transition metals, they have unpaired electrons in their d orbitals. So most of the transition metals, they are paramagnetic in nature. So whenever you have unpaired electrons, means that transition element, it is showing paramagnetic properties. If you have paired electrons, suppose there are paired electrons present, then they all the electrons are paired, that means they are showing diamagnetic property. Okay, then transition metals ions having 3d0 means what? 3d0 means what? D means 1, 2, 3, 4, 5. Okay, 3d0 means what? In their d orbitals, there are 0 electrons. Okay, and 3d10 means what? 1, 2, 3, 4, 5. So 1, 3d10 means all the 10 electrons are filled. Okay, so you can see. So when you can see now here, there are 0 electrons. 0 electrons means, is there any electron or unpaired present? No. So they will show what? They will show diamagnetic property. And when they have 3d10 means all the d electrons are having 10 electrons. All the d means what? 5. D in D there will be maximum 10 electrons can be filled. So all the 10 electrons are paired. Is there any unpaired electrons? No. So whenever you have 3d0 and 3d10 configuration, they will show diamagnetic nature. Okay. So these are certain properties. The total magnetic moment of a substance is the resultant of the magnetic moments of all the individual electrons. Okay. So these are the certain magnetic properties of. Is it clear till here? Yes. Yes, whatever we have discussed, it is clear. Okay. So next is non-psychometry. What do you mean by non-psychometry? Non-psychometry means whenever the compounds, okay, as we have seen that in transition elements, they are large size. So in between there will be interstitial species. So interstitial size will be there. So in that, small atoms like carbon, oxygen, hydrogen, they will occupy. Okay, so these non-psychometric means what? The composition will be not fixed. So the transition elements sometimes form non-psychometric compounds due to variable valency. Valency means what? Suppose okay, cerium, it will show +2, +4. So like this. So variable oxidation states will be shown by some of the elements. So because of this reason, so because of variable oxidation state, so they form psychometric compounds. So these compounds are indefinite structure and proportion. Why they are having indefinite proportion? Because it is non-psychometric, because the composition is not similar. Okay, because the composition is not fixed. Okay, because of this reason, they are indefinite structure and they are having indefinite proportion. Then, for example, iron 2 oxide FeO should be written as a bar over the formula. Fe and O atom is not exactly 1:1. So whenever you are forming any non-psychometric compound, suppose this is a psychometric compound, then we can say what? 1:1. That is Fe, one atom of Fe is present. For that, one atom of oxygen is present. Non-psychometric means what? Here you can see Fe, okay, FeO, that is Fe is 0 and 94 is oxygen. 94 is oxygen. So Fu like this. Okay, so the composition is not fixed in non-psychometric compounds. Non-psychometry is shown particularly among transition metals. So non-psychometric compounds, they are particularly shown by transition metals of group 16. So along with the group 16. Sometimes non-psychometry is caused by defect in the solid structures. Okay. So these are certain points. And we have seen what is alloy formation. So alloy formation is what? It is a homogeneous mixture which is formed by two or more metals. Okay. So what is the example? Example can be brass. Brass is formed by copper and zinc, and bronze is formed by copper and tin. Okay. So these were some of the properties. So in the next class, okay. So today we have covered more. Okay. So we have seen what all. I'll just discuss once and then we will stop the class. Okay, the remaining part we can continue in the next session. So we have seen the general properties of D block. So what are the metallic strength? Okay, what is the metallic strength? Then we have seen the different metallic properties. Okay, so so these were some of the important points from D block elements. Then we have seen some general properties. We have discussed about the general properties of transition elements. Then we have seen the metallic character. Okay, how does transition metals, as we know, transition elements as they are metals. So what are the different properties of metals we have discussed. Then next we have discussed about the reducing power. Okay, then we have discussed about the density. Then we have discussed about the melting point and boiling point of D block elements. Then formation of complex compounds. See, formation of complex compound is very important. Okay, very important. So why they form large number of complex compounds? What is the catalytic properties of transition elements? How they form interstitial compounds? Very important concept. Then next is alloy formation is very important. Then color property is very important. So these are certain transition elements, why they are different from other elements. So these are certain properties which highlight them, so these are certain properties which highlight the transition element from rest of the elements. Okay, so color property, catalytic properties, magnetic properties, alloy formation property, right? So these are certain important properties of transition elements. Then magnetic properties, then non-psychometric. So we have seen today. So next class we'll see some of the important compound of transition metals. So there are two important compounds, and then we will see the F block elements. Okay, so this is all theoretical part. D and F block element, these are all theoretical part. So most are all theoretical. So based on that only we are going to see some of the important points. Okay, so any doubts here, whatever has been taught in today's session? Any doubts? Do you have any doubts? Yes. Any doubts? Then I feel there are no doubts. Yes. Yes. Okay, Priyanka has one doubt. Everybody is there, right? Okay. So what she's asked? What is reducing power? Okay. What is reducing power? So generally what is reducing power is what? Reducing power means what? It is the potential or the power of any substance, okay, to reduce another substance. So reducing power means what? One substance. Now suppose there are two substances. Okay, now one substance which is having that reducing power, it will try to reduce another. Okay, whoever. So suppose now there are two substances. Okay, you have seen in redox reactions. Okay, you have seen in redox reactions. So in redox reactions there will be two elements. Okay, so this will be there. So what will one do? So one element will reduce another. Okay, suppose this is there, this is there, so this is having the reducing power. Okay, this is having the reducing power. So what it will do, it will reduce another, and itself will undergo oxidation. Okay, it will undergo oxidation. Reduces other means what? This will gain electron. Okay, it will gain electron, and oxidation means it will lose, there will be loss in electron. So reducing power means what? It reduces other. Okay, it will reduce other, and it will undergo oxidation. So either how it will be, that only reduces other means there will be gain of electrons, and here it will have it itself, it will undergo oxidation means there will be loss of electrons. Now when you're talking about transition elements, now when we are relating it to transition elements, as we know, as we go across the period, now across the period what will happen to atomic size? As we'll go across the period, the atomic size goes on decreasing. Okay, you know, the atomic size goes on decreasing. What will happen to nuclear charge? Nuclear charge increases. Nuclear charge means what? The affinity between the nucleus and the outermost shell, it goes on increases. The nucleus will tend to pull the outermost electrons more strongly. So because of that, the nuclear charge will increase. So electron affinity and ionization energy will also increase. Ionization energy means what? The energy which is required to remove the electron from its isolated atom. Okay, so because of this reason, so what will happen? So because of this, okay, so it goes on increases. So therefore the tendency of the electrons, what will happen? It decreases across the period from left to right. So because of this, the reducing property also decreases as you go down. So in transition elements, when you are talking about transition element, the reducing power, it will be less. Okay, so some more if you want. Okay, So she's convinced, fine. So if you want anything else, in the next class with example, I'll tell you, okay, for reducing power. So anything else, any other doubts? Okay then, so I'll end the session here. Okay then, so I'll end the session here. Okay, so we'll meet in the next class. Thank you.